So there's a holiday this week and we don't have class on Thursday and I will not have a Zoom meeting on Friday. For the rest of the semester, we're talking about graphs. So for the next few weeks, notes on graph theory. And I plan to post homework for graph theory, the first homework for this topic today, but it will be due next week on Thursday to give time for that little holiday weekend. I think that's homework number 7. Next week on Thursday is the 30th. I'll double check, but it should be 11:30. Oh, nope, it's the 2nd. So that's Tuesday. We're gonna go Thursday, December 2nd. Okay. So at the end of last class, we had a result, and after working with another class, I want to just mention that this should work for any graph. If it's got loops, if it has multiple edges, if it's disconnected, you can use this theorem. Again, I checked in the book and this should work for any graph. All right, the sum of the degrees of all the vertices equals twice the number of edges. Okay, so the vertices are the dots, and the degree for each dot or each vertex is how many edges go to that vertex. And again, edges are the lines or the connections from dot to dot. Okay, another way to say this, or like the shorthand way that I use, is if you want the number of edges, you find the sum of degrees and divide by 2. Number of edges would be equal to the sum of the degrees divided by 2. So I have an example that's similar to the example we did at the end of last class, but I just want to go over it again and make a couple more examples. And then for the rest of class, we're going to work on applications of this theorem. Okay. So for the first graph, we are going to draw 5 vertices. One, two. Okay. From this vertex, we're going to connect to all of the others. This vertex, we're going to connect to each other vertex. Here, we're not going to do a multiple edge, we're just going to use this edge, that vertex, and that one. And the last part was a loop on one corner. So to do the degree quickly, we're going to put it in parentheses right next to the vertex as a label. And the degree is the number of edges that go to that vertex. So you can highlight like just where the edge meets the vertex. Have 1, 2, 3, 4 times. This would be 2 times. Or degree 2. Same here, degree of 2. Okay. 1, 2, 3, 4, degree 4. 1, 2, and the loop gives 2 more. So this is 4. Okay. Number of edges. Okay, so sum degrees means sum all of the degrees from your graph and then divide by 2. Add 4 with 4 plus 2 plus 2 plus 4. Four plus 4 plus 4 plus 4, so 8 plus 8 is 16 over 2. 8 edges. And then we're going to highlight every edge to use the graph as like a way to count and check that we did get this many edges from the theorem. Okay, we're going to do once, twice, 2 edges so far. And then there's 3. And go over to the side with 5. This would be 6. And then across is 7. And the loop is 8. Okay, we're going to do another graph. This was from a student, and I really liked the picture. So we're going to do a triangle with 2 loops. And from this graph, we're going to get the number of edges. we've got a triangle and there's two vertices that have loops. I'm going to practice using this theorem. To get the number of edges, I can find the degree for every vertex, add them all together, divide by 2. So let's go here with degree 2. This would be degree 1, 2, and from the loop you get 2 more, so it's 4 total. Same here, 1, 2, 3, 4. Number edges would be to sum the degrees, divide by 2. Okay. 2 plus 4 plus 4 over 2. Okay, so you've got 10 over 2. I'm going to do one more graph, just a plain old graph, and use the result. And we're going to start doing some kind of like word problems. Okay, so maybe in the future we'll try this result on a disconnected graph, but for today, all of my graphs are just going to have one component. So it's connected graphs for today's examples. Okay, start with 4 vertices. Okay, 2 more down below. This vertex is going to connect up here and make kind of a triangle. And the same over here. Okay, we're going to connect here to here. And here to here. And the last part is to have a multiple. No, it's not a multiple edge. This is just another edge. Here to here. If we went from this vertex to that vertex, then you would have multiple edges right there. But because of this vertex splitting this up right here, this is not really a multiple edge. It's just another edge. Okay, we're going to use this graph and label every vertex with its degree. This would be degree 2. 2 edges. This would be 1, 2, 3, 4, degree 4. This has 3 edges going to it, so it has degree 3. Same here. 1, 2, 3 edges meet that vertex. Degree 4, right here. And 1, 2, 3, 4. Degree 4. From the theorem, the number of edges is the sum of degrees divided by 2. In this graph, we're going to go with 3 plus 4 plus 4 plus 2 plus 3 plus 4. Okay, let's see. The 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 over 2. Okay, at 10 edges. And we're going to actually just use the graph and highlight all of the edges, make sure that there are actually 10. Let's go from here with 1. This is 2, 3, 4. Each edge goes from vertex to vertex. So 4 so far. This would be 5, 6, 7, 8, and then 10. Okay, so for the rest of class, I need to use an old worksheet. So the first problem is to have 2 teams playing a game. 2 teams of 5 people play a game, and each team is expected to shake hands with everyone on the opposing team, but not anyone from their own team. And then everyone on each team will shake the hand with everyone on the opposing team. how many handshakes are possible? I think that's 2 words. It might be 1 word, handshake. It's the same question. I just need space to draw the graph. Okay, so just so you know, there will be some kind of question similar to this on your last exam. So I'll do practice problems today, of course, more during review week, and we'll put some on your homework. Okay, 2 teams. So we're gonna have team 1 on this side and team 2 on this side. I'm also gonna use another color. Use green for one team and black for the other. 5 people on each team. So this side we have 1, 2, 3, 4, and 5. 5 people on the first team. And then across from them, we're gonna put the other 5 people represented by vertices. 1, 2, 3, and 4, and 5. Okay, so each of these people shakes hands with all of these people, but we're not going to have any connections from them to anyone on their own team, because I kind of erased that part, but they're only shaking hands with people on the other team, and they have to go through every person on that team. Okay, so for every handshake, we'll use an edge to represent that event or that relationship. Okay, so the first person meets from the black team or the first team, shakes hands with this person and that person, that person. Okay. Same for this guy. He shakes hands with everyone from the other team. So we'll draw an edge to each vertex. Okay. Same thing here. We're going to meet this person, that person, that person, that person, and the last one. Okay. This person has their turn to say hi to everybody on the other team. And the last person does the same thing, connects to every vertex on this side. So it looks pretty messy. We're not going to count the number of edges by hand. We're going to use the theorem. So we're going to find the also, before we do that, I want to show you that if you go to this side and you check that this person here has met all of the people over there, they did. And we've taken care of this person saying hi to all the other people. They have a connection to each dot on this side. And then as you go down, this person shakes hands with all of them, this person shakes hands with all of them, and this person does the same thing. So this is the graph I want. And now I find the degree of every vertex, add it all together, divide by 2. we want the number of handshakes, which would be the number of edges. So sum the degrees and divide by 2. All right, let's start on this side. So we've got 1, 2, 4. 4 connections. So it's degree 4. Wait. There's 5. These ones come really close together, but there are 2 right here. 1, 2, 3, 4, 5. So maybe a bigger, kind of more expanded graph would be better. But this one also has degree 1, 2, 3, 4. After checking, they should all have degree 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. This side, once, twice, 3 times, 4, and 5. You remember that from every one of these, we went and met with all 5 people over here. So all of them are going to have degree 5. Okay, so 5 plus 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 5. Add all this together. So let's see, 10, 20, 30, 40, 50. When you sum all of the degrees. So there are 25 edges. Every edge is a handshake, so we can have 25 handshakes. Okay, next one are 5 people at a conference table, at a big circular table. Everyone gets up and shakes hands with everyone who did not sit next to them. And then find how many handshakes are possible. 5 people. Everyone gets up. And they meet or shake hands with each person who did not sit next to them. So we're going to pretend the table's here, a big circle. We have our 5 people sitting around. It's like a little bit spaced out from each other. Okay, these are my people, all 5. Then each person shakes hands with people who did not sit next to them. So this person does not want to meet either of these people, but does say hi to the other 2. So this way. So this person does not connect with these people who sit across from them, but does meet the ones over here. This person is not going to shake hands with that person or that person, but does meet the other 2. These people have already met. These people still need to shake hands. Going this way. This person does not meet the people sitting next to them, but does meet the ones across, which you've already taken care of. Here, this person doesn't say hi to these people, but does say hi to those ones. Back, we're almost done, I think. This person does not connect to the other 2, but does go across. And then we go. So this is the graph. Looks like a star. We want the number of edges. Every edge was a handshake. Every edge represents a handshake. I want to know how many handshakes there are, means I want to know how many edges there are, and use the theorem. Find the sum of the degrees and divide by 2. Okay, every vertex has degree 2. So there's 2 connections. Same here. 1, 2. 1, 2. From here. Add all of the degrees. So 2 plus 2 plus 2 plus 2 plus 2. And then divide by 2. Okay, 2, 4, 6, 8, 10. And then 10 over 2 is 5. Handshakes. And then you can, on this graph, you can't actually count. We can maybe highlight like 1 and 2, there's 3, then 4, and okay. So keep on going to next word problem, which would be some people at a conference meet each other by exchanging cards, business cards. At a convention, okay, CON. We're going to say that they connect with each other or meet, either way, connect with each other by exchanging business cards. For one another. If two people exchange cards, they make a connection. How many connections are made if, and then we're going to have multiple parts. So first of all, if two people meet, or if two people exchange cards, they have a connection. How many connections are made? So, the first part, if 6 people at a convention each end up with 3 new cards. Okay, 6 people and each of them get 3 cards. Okay, so just to like, so just a side note, I do not like to trick students. So some of these graphs are tricky, and those are not the kind of graphs I'm going to put on your test. So when we get ready for your test, I will show you the process for the kinds of graphs you'll need, which won't be too terrible. I have a feeling that some of these are going to be a little difficult to draw, so don't stress out if you have trouble drawing it, because I may even need to piece these graphs together. But I have some guides. Okay, so first we're going to draw our 6 people kind of in a circle. One, two, three, four, five. Okay, so we need to draw this graph in a way where every vertex has 3 edges connecting to it, and that's all we need. But that's not super easy. But let's draw this together, and I feel like we can get it in the first try. And I'm just kind of saying this because I used to do these problems as group activities, and sometimes the group would need to get help on how to draw the picture. But once you get the picture, you use the theorem and get an answer. Or once you get the right graph. All right, from this vertex, we're going to go straight down, over and over. So that person got 3 cards. Okay, this person already has 1 card. We're going to, so I drew a graph so that they get another card from this person. And this person. Let's go here. This person has already gotten 1 card. I had them get another card from the vertex right at the top, that person right there, and the one straight across from them. So they've got 3 cards, and that's what we need from that vertex. Okay, this person has 2 cards, but we want them to have 3 cards total. We're going to have them get another card from the guy over here on the edge, or the person on the edge. And that has 3 cards, so that's good. We're on our last, or second to last person. They've got 2 cards. They need 3. So, and this person has 2 cards. They need 3, so we'll have them meet each other. And this is one way to draw the graph that matches this problem. So all 6 vertices have degrees 3. 1, 2, 3. And 1 stripes. Okay, so what we want is the number of edges in the graph, which we can count, but if the graph is messy, I would want to use the theorem. So the practice, adding the degrees and dividing by 2. First of all, every vertex is a person. And all of the edges are connections. need the number of connections. So I want the number of edges. Okay, number of edges is the sum of the degrees over 2. Okay, we're adding 3 with itself 6 times. Wait, 1, 2, 3, 4, 5, 6. Yeah. Okay, 3 with itself. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 2 or divided by 2, which would be 9. 9 connections or 9 new cards. Either way. We're gonna put connections. New cards is for how many cards each person got, which just helped us put the graph together. Okay. We could probably do 2 more of these today. So the next one, we still have the same people at a convention and they exchange cards with each other, but we're going to look at 2 people who each get 4 cards and 4 people and each of them gets 2 cards. Two people. Also, there are 4 people who get 2 cards. Okay, so these 2 people get this many cards, and then there's also 4 people, so we have 6 people total. I want to draw 6 vertices. Each vertex represents a person. So, scratch work. And every vertex will be a person. And the edges are going to be connections. Okay. We're going to draw our 2 people at the top. The 2 people who get 4 cards. And then the 4 people who get 2 cards each are going to be in a row down here. It doesn't have to be perfect. I'm just trying to help make a nice looking graph. Okay, so this person here, one way to draw the graph is to have the person here get one card from each of the ones below. That way that person has 4 cards or 4 connections. The other person who gets 4 cards, have them get it from all of the people down below. That way each of these 4 guys here, the 4 people here, each get 2 cards. So 1, 2, 1, 2. Okay. What we want is the number of connections, which is the number of edges. So I want to know how many lines are in the graph. And in this graph, we could probably just count, but we want to try using the theorem instead. So label every vertex with its degree. This is a degree 4, degree 4, degree 2, degree 2, 2, and 2. Okay, sum of the degrees and divide by 2. So from there to here, the sum of the degrees is going to be 4 plus 4 plus 2 and 2 and 2 and 2. Eight plus 2, 4, 6, 8. 16 over 2 is 8. It says 8 connections. I'll just put it right here. Cool. I think there's time for one last question like this, and then I'll maybe do some more next week. Okay. Part C. We're going to have 3 people who each get 4 cards, 2 people who get 3 cards, and 1 person gets only 2 cards. That's okay. All right. First part is that 3 people who each get 4 cards. Just 3 people. 2 people get 2 cards. 2 people get 3 cards. Something's wrong. 3 people get 4. There's 2 people who get 3 cards. And 1 person gets only 2 cards. We're going to find out how many connections were made between this group of people. Okay, let's start with some scratch work. And make it clear that every vertex, every person is represented by a vertex. Okay, each edge is a connection. Okay, so I want the number of edges, which is the number of connections. So we're going to try to draw the graph. And I have one way to describe that situation with the graph. So I drew my dots kind of in a circle. I'm going to do shorthand. There's 3 people who get 4 cards. 2 people get 3 cards. 1 person who has 2 cards. Okay, so I got a graph from drawing the vertices like this. 3, 4, 5, 6. 3, 4, 5, 6 people that I need in the graph. The person here is going to get a card from all of the people here except the bottom one. So we're going to connect like this. And label that we've got 4 cards going to that person. 4 connections. Okay, then go here. So there's 1 card, and then we're going to get 3 more from these people, not this one over here. So we're going to connect to this guy, this one, that one. There's my 1, 2, 3, 4 cards. Okay. Let's go over to this side. This vertex has one connection or 1 card goes to that person. They're going to get cards from all 3 of these people, but not this one that's labeled with a 4. So we're going to connect here, here, here. Screen 1, 2, 3, 4. So what is left is actually the correct graph. So if we look at the rest of the people, so far we've got 3 people with 4 cards. Check. We need 2 people who have 3 cards, which this is degree 3. This vertex has degree 3. And then 1 person has 2 cards, which is that one at the bottom. This person here has 2 connections or 2 cards that they have collected. So number of connections. And this problem, it means we want the connections are going to be the edges. So the number of edges. You could count, or you could use the theorem. So you can find the sum of the degrees and divide by 2. Okay, 4 plus 4 plus 4, and 3 and 3 and 2. And if you can kind of, I mean, if you feel confident piecing this problem together without a graph, that's okay, but it is possible to draw a graph for each of these. And that's what I would do for scratch work. I like to draw. Okay, anyway, the sum would be 12 plus 6, be another 2 more would give me 20, and then divide by 2. So I should have 10 connections. And we're going to call it the end of class today, leave 5 minutes early. Again, we do not meet on Thursday, it's a holiday. And I am going to post homework this week, but it won't be due Tuesday, it will be due Thursday. Okay, thank you for coming to class. Stay if you have questions.